In this video, we're going to look at how we can generate equivalent expressions. To do this, we're going to first define what is an equivalent expression, just in case you don't know. Then we're going to look at the properties of operation. There are three of them. Really, there's one that's super important. And then we're going to use those properties to help us generate equivalent expressions. So, evidence-wise, not too bad. Learning experience-wise, same thing as always. So what does equivalent actually mean? If you're not familiar, equivalent expressions have the same value regardless of what value is substituted in for the same variable in each. That's a really fancy way of saying after you do your substitution, they should give you the same value. So for example, we've got two expressions here. We have 4x and x plus 4. Now just looking at those, you can probably tell that they're the same expression, but let's just pick a value for x. Let's say that's 2. If we substitute in 2 for x, we should see that those two are going to be equal. And sure enough, we find that 6 does in fact equal 6, so we know that these are equivalent. This should also work for anything that we pick for x to be. So if we picked 100 instead, these two things should still be equivalent, and sure enough, 104 is still equal to 104. So that proves that these two expressions are in fact equivalent. So now let's look at our properties of operations, and I would highly suggest, by which I mean do this, write these 3 things down, or 6 things, I guess, depending on how you think of writing them. We have the commutative property. There are 2 of them. There's one for addition, one for multiplication. Basically what that says is that it doesn't matter what order you add or subtract in, they should be the same. So for example, a plus b is equal to b plus a. We literally saw that in the previous example on the previous slide. There's one for multiplication as well. It works the same way. The next one is the associative property. Again, there's one for addition and one for multiplication. Those are slightly different, but they're the same basic ideas, though they can be useful in some situations. Basically the same thing. It doesn't matter even if you've got stuff inside of parentheses. If all you have is addition or multiplication, they should be the same. Finally is the distributive property. This one, I would suggest putting a star next to in your notes, because this is the most important one out of these 3. You use the distributive property all the time in real life. It really is the most useful thing. There are 2 versions of it. There's an addition version, which shouldn't surprise you, and then there's also a subtraction version, which is basically the same thing. It just means that your addition sign, your plus sign, is going to turn into a minus sign in either one. And just to show you what this might look like, if, for example, we had 2x plus 2, if we did our distributive property, this should end up being 2 times x plus 2 times 2, which you can then go on to simplify. That's basically all that it does. The word distributive, if you think about the word distribute, that means like you're giving something to something else. That's basically what you're doing here. You're taking your 2 that's in front of your parentheses, and you are distributing it. You are giving it to each of the terms inside of your parentheses. So each of these now has a 2 being multiplied by it. That's kind of the idea here. Let's look at a more in-depth example. So in this example, we have 2 different expressions. We want to check if they are equivalent. So looking at this one, that looks like it's pretty much set to go. So really we want to check to see if this expression is equivalent to this one. So to start off, we're going to start by looking at just this first section here. If we look at how that's set up, that looks a lot like the a times b plus c. So we know that via the distributive property, this should be equal to a times b plus a times c. Our a in this case is going to be 6. our B is going to be n, and our C is going to be 3. So we can just use that information to help us make an equivalent part of this expression, at least. Another way of thinking about it would just be to say that we're going to take the 6, we're going to multiply it by both n and by 3, depending on what works best for you. So now we're going to have 6n plus 3 times 6, and then we still have that minus 4 on the end. We can do 3 times 6, which will be 18. We still have the minus 4. And now we just have to do a little bit of subtraction here. We have 6n plus 14. So, did we end up with this? Yes. They are going to be equivalent. So that's where you might use the distributive property in real life. Notice that the most useful one there was the distributive property as well. Additionally, we still had to follow PEMDAS. We still dealt with the multiplication / parentheses section before we could deal with this subtraction part. So it's all kind of coming together right now. Next, you're going to try this you-do problem. You're going to find an equivalent expression for 3 times the quantity x minus 6. Look back at your notes at the various properties that we have. Which one's going to be most useful for you in this situation? Ready, go. So, things to remember. Expressions are equivalent when you substitute for a variable, and they give you the same value. That's just what does equivalent mean. Things should be the same. You can use the properties of operations or the POO to generate equivalent expressions. Really, the most useful one for that is probably going to be the distributive property, because if you ask me, it is the greatest thing since sliced bread. Remember the distributive property. I can't stress enough how important that property is. Write it down, put a big star next to it, paint a painting of it, hang it on your wall. I don't know. Make sure you remember it. Get it tattooed on yourself if you want. That might be a bit extreme, but it's that important. Yeah. Finally, let's look at some suggested practice problems. There are 6 of them here for you. You're going to use the properties of operations to generate equivalent expressions for each of them. Some of them are more challenging than the others. Most of them use the distributive property, but there is one that actually uses one of the other 2 properties, so be careful of that. The last 2 there, the 5w minus 15 and the 2x plus 4y, you might have to do the distributive property backwards. Subtle hint. There's also a challenge problem there. That one's similar to our example problem, just a little bit more in depth. Again, you're actually going to use multiple properties there, if you think about it. So, good luck.